Alright class, in today's video we're going to kind of review our exponent rules and talk about one last rule that we have. So just a quick overview, we've got x to the a times x to the b. When you multiply the same bases, we add the exponents, so x to the a plus b. If you have x to the a raised to the b, so now you have a base raised to an exponent raised to another exponent, so a power of a power, we have x to the a times b. You multiply them. Anything to the 0 power we know is always 1. Then we have this rule where it's x times y to the a power. So if you have a product and you raise that to a power, you hand out the exponent to each of those. So we have x to the a, y to the a. It's kind of, we give out the exponent to each product, each factor in the product. Same with a quotient, so if it's x over y to the a, I'm going to give out the a to both the x and the y, so it would be x to the a over y to the a. And finally, we saw yesterday, if you have a negative exponent, it becomes the reciprocal, so 1 over x to the positive power, x to the a. So our new rule today, and our last rule, is having to do with division. So if we have a division problem like you see here, x to the a over x to the b, it really is very similar to our product rule, right? If it's x to the a times x to the b, we added the exponents. So here we're going to, if it's division, subtract the exponents. So this rule here is going to be x to the a minus b, right? Quick example of what that looks like. If we had, let's say, b to the 7th over b to the 4th. Okay, well really that's b times b times b times b times b times b times b. 7 b's on top and 4 on the bottom. And we know from division, if you're dividing something by itself, it equals 1. And so 4 of these b's can cancel out, and we're left with 3 b's left over. So the answer there is b to the 3rd. And look at the exponents, 7 minus 4 is 3. Okay. So let's try a couple examples. Number 1 down there, we have x to the 10th over x to the 7th. So what we're going to do is subtract the exponents. It's x to the 10 minus 7, which is x to the 3rd. I like to think of it kind of as a tug of war, right? We have 10 x's on the top, we have 7 x's on the bottom. Well, which team's going to win? The top. And how much is it going to win by? 3. So we get x to the 3 left on top. In a way, we still have over 1, but usually if nothing's left on the bottom, you don't have to write the 1. In number 2, we have a to the 3rd over a to the 5th. So in this case, if I use the rule, I get a to the 3 minus 5, which is a to the negative 2. And we don't want to leave a negative exponent, so then I'm going to use my negative exponent rule, which says I should put it in the bottom. So it's 1 over a squared. In this case, we do need the 1. There's nothing left on top, so you can't leave a numerator empty. So we have to have a 1 in the spot of the numerator, 1 over a squared. Okay. Here's another tug of war. It's a to the 3rd. There's 3 a's on the top. There's 5 a's on the bottom. So if we think about that as a tug of war, which team's going to win? The bottom, right? That a to the 5th on the bottom overpowers the a to the 3rd on the top. And how much does it win by? It wins by 2. So that's why you could really go straight to that answer there, knowing that there's going to be 2 a's left over on the bottom, and since there won't be anything left on top, we have to put the 1 there. Example 3, we have negative 2 to the 8th over negative 2 cubed. So for this problem, we have negative 2 using the rule to the 8 minus 3. I subtract my exponents, and we get negative 2 to the 5th. And that really means negative 2 times itself 5 times. So when you do a negative times itself an odd number of times, you're going to get a negative answer. And 2 to the 5th is 32. 2 times 2 times 2 times 2 times 2. That'd be 32. So we get negative 32. Problem 4 here, we think about it as a tug of war. 5 to the 3rd over x to the 4th, or excuse me, over 5 to the 4th. They are the same base. So right away, I'm going to think of this as the tug of war. The bottom's going to win. So I'm going to have 5 to the 1st left over in the bottom, and I need 1 on top. So this is really just 1/5. Okay. You could go through the whole thing of 3 minus 4 and say it's 5 to the negative 1, and then you bring it to the bottom, 1 over 5 to the positive 1. Let's finish with a couple practice problems of putting some of these rules together. So number 4 here has a lot going on. I'm going to jump right into a tougher one. And in this problem, we've got a fraction. We've got a situation where there's an exponent on the outside of some parentheses. So the first thing I see is I should hand out that 4 to all of the variables inside the parentheses. I need to get rid of the exponent outside the parentheses. So I get 2 to the 4th, x to the 12th, y to the 20th. Remember, when you do this, you multiply the exponents. Because it's really like I'm saying x to the 3rd times x to the 3rd 4 times. Over the bottom, I don't need to do anything. 8 x to the 5th, y to the 30th. And now I have do you see the two tug of war games we have? We have y in the middle of a tug of war game. And we have x in the middle of a tug of war game. And then we're going to have these coefficients. These aren't variables, so I don't need to worry about them from a tug of war standpoint, but I do need to simplify the top of 2 to the 4th. So let's do this. We've got that this is going to equal 2 to the 4th is 16. Okay. If I look at the tug of war for x, it's 12 on the top, 5 on the bottom. So I'm going to be left with 7 x's on the top. Or you can think of it as subtraction. X to the 12 minus 5 is x to the 7th. For y, who's going to win that tug of war? It's the bottom. So you could go straight to y to the 10th on the bottom. Or I could use my subtraction rule, and I could say 20 minus 30 is negative 10. Okay, and then I'm still over 8 on the bottom. And now I have two things I need to do. I need to actually divide, oops, that's not the highlighter. I need to actually divide 16 by 8, and I need to move the y to the negative 10 to the bottom. So to finish this problem off, we're going to get 16 divided by 8 is 2, x to the 7th, over, and when I bring the y to the bottom, now the exponent becomes positive. So a negative exponent just moves to the opposite part of the fraction. That's number 4. We get 2 more quick ones. In number 5, so let's see, I have a to the negative 2nd times 3 on the top. I have 6 to the negative 1 times a to the 5th on the bottom. So I tend to like to deal with negative exponents first. So if there's no big outside exponents, I'm going to move the negative exponents to the opposite parts of the fraction. I'm going to say 3 over, I'll bring the a to the negative 2nd to the bottom. So on the bottom, I'm going to have a to the 5th and a to the positive 2nd, because when you move it down, it becomes positive. And then the 6 to the negative 1, I'll move to the top, and it'll become times 6 to the positive 1. Well, there I have 3 times 6, which is 18 on the top. And on the bottom, I have a to the 5th times a to the 2nd. So I add those exponents, a to the 7th. That's your answer there. Finally, number 6. This one's going to use that kind of quotient rule where I have an outside exponent on a fraction. So I'm going to hand that out to everything in the fraction. And the mistake people make is not handing it to the 2 also. So this is going to start off as 2 to the negative 3rd, g to the negative 3rd, over h to the negative 6th. Multiply that. I have 3 negative exponents, so let's move everything, right? Every negative exponent gets moved to the opposite part of the fraction. So the 2 to the negative third is going to go to the bottom and become 2 to the third. The g to the negative third is going to go to the bottom and become g to the third. And the h to the negative 6 is going to go to the top and become h to the 6th. Okay, I don't have any like exponent bases here, so the last thing I just need to do is figure out that 2 to the third is 8. 2 times 2 times 2. So it's 8g cubed on the bottom, h to the 6th on the top, and that's it. So that's all our exponent rules. Thank you for watching.